Okay, so hello everyone. We will present to you today our topic, improved connectivity during live migrations, and we'll explain you our challenge to stable the process and connectivity during live migration. At first, who we are. I'm Lamprecht. I'm working at Stefan, which is the cloud provider of the Schwarz Group and also for external customers. The Schwarz Group is known for its big retailer brands, Lidl and Kaufland, and also the recycling brand Pre-Zero.
I'm Stefan Hoffmann from Cloud and Team Technologies. We are a cloud technology and cloud service provider, and for example, we built together with Schwarz IT the Stefan Cloud, and together we also built the open source project Yahoo, which is in lifecycle management for OpenStack. We want to present you the problem or issue we got reported. Then, because it turns out it has something to do with live migration, we will introduce a bit how live migrations are working in OpenStack. Are going a bit into the debugging, and then present you our solutions for that issue. So, what is the issue we heard? We got reported that there was connectivity issues for VMs, and from around 30 seconds there was package loss or downtime. These are mostly, or was mostly, load balancer VMs, so we saw VRRP failover there, and this got reported mainly by other teams at the Stefan Cloud, but also by customers. And what was interesting, this was mainly about small VMs. A nice thing was there we could reproduce the issues, and so with the lifecycle management Yahoo, we do often live migrations for changing configurations, updating, and so on. But we could pause this process so we don't trigger new live migrations till the issue is fixed or was fixed.
Okay, so after we paused all the live migrations, we first started to debug the issue. First of that, obviously, we tried to reproduce it, and as Stefan already mentioned, it was possible, but only with small VMs. If we use big VMs with over 100 gigabytes of memory, for example, we couldn't reproduce it. Yeah, after we reproduced it, we obviously first thing that we did was googling the issue or checked on Launchpad or Garrett for similar bugs, and there we obviously found bugs, but mostly related to the ML2 OVS networking plugin and not for OVN. There are also settings called live migration wait for WIF plug, but that we already had enabled from our good old ML2 OVS times in the past. But for OVN it didn't help us, and we had still the issue that we faced the issue. So after that, after finding nothing on the internet, we did a deep dive in live migration and asked ourselves first, how do live migrations even work? So at first we will talk about the Nova process. The Nova process has multiple steps. First of all, after the live migration gets executed, there are migration pre-checks, mainly between the source and destination node to check, for example, if it's the same architecture, are we capable of migrating between the two hosts. If not, it goes back to the scheduler or conductor and we retry it on another host. If the migration pre-checks are successful, we use these two hosts and we start the pre-live migration. The pre-live migration, the main step of it is setting up on the destination hypervisor all the things that are needed for the VM, such as, for example, if you use NFS-backed instances, mounting the NFS shares, and also creating the port binding. Creating the port binding is done via an API call to the Neutron, so the network API in OpenStack. And it's just one API call, creating the binding, and after that the pre-live migration is more or less done. So also to mention, this is only a rough overview. It's way more complicated, but this is just the main parts. After the pre-live migration, we have the actual migration. So the actual migration consists of you have local storage, copying over the storage, and also copying over the memory, or sync it up to 100% and then do the switch over. After the switch over, we go to the post-live migration section. During that, we have on the source side then the tear down, so removing the old VM configuration, cleaning up the source hypervisor, and also again an API call to the network API to remove the port binding on the source host. So that's more or less the process in Nova, and for us that looked really good, and we didn't find there any issue yet. So we thought about, we have these two calls for the network API. Let's investigate more what happens on the network side. As we said previously, we use OVN. OVN is separated into multiple components. So first of all, we have our CMS, which is OpenStack Neutron, where we have the API calls, which are, for example, if we create a port, it gets first written into the MySQL database of Neutron to store it there, and it also gets written to the northbound database. The northbound database is a OVSDB database of the OVN core components, which stores the logical representation of a network. So where you find all the informations like routers, networks, and everything that you have in your environment. Below that, you have the southbound. The southbound is also an OVSDB database, but way more information. So it's you have also the logical information, but also the physical information. So, for example, in the southbound, you have which hypervisor needs to talk to which hypervisors, which tunnels do you have, what connections do you need between, so you have all the logical flows basically. And from a compute perspective, every compute node has a connection then to the southbound database. Basically it's also a watcher, so the compute node gets notified by events happening on the southbound, for example, creating a new port on that particular hypervisor. The OVN controller will see it, so get the notify event, and then provision the port on the OVS vSwitch-D and attach it or provision the flow on the hypervisor on the Open vSwitch itself. What happens there during a live migration? As stated out previously, we have the API call for the port binding on the destination host. The Neutron service also stores it on the MySQL database, and afterwards it writes it to the OVN northbound database. In the northbound database, you have a table called logical switch port, which is the port, all ports are there located from compute nodes, so VM ports. And OVN has the feature of multi-chassis bindings that you can enable by setting multiple chassis to request a chassis. So a chassis is in the OVN language is the same as the term hypervisor or device that is used by OVN. And in the request a chassis section, normally you have only one hypervisor written in, but you can also write multiple list into that field, and then you have your primary and secondary hypervisors that claim the port. This is basically done by the live migration. So then the source and destination compute node can have flows provisioned and the ports plugged for the live migration event. The second option that also Neutron sets on that port or logical switch port is the activation strategy reverse up. The activation strategy is the strategy or is the event that gets triggered by QEMU or the QEMU process after the live migration will send out multiple reverse ARP packages that the logic or that switches know that the VM is now active on that hypervisor or behind that MAC address and behind that port. So Coemo will send out these RAR packages in the OVN term. The activation strategy reverse up means that the OVN controller will listen now after we set it to the port. The OVN controller will listen for these kind of packages, and if it sees these packages on the destination hypervisor, it knows that the migration was now completed, and the new active hypervisor is the compute 02 in our case, so the destination hypervisor. That also made sense to us that it worked like that. After that, we still didn't have the root cause. We know now how it works, so now we are trying to catch the root cause. Our first thought were that neutron or OVN is maybe too slow to propagate it to all these stages. So what we did then, we wanted to create a timeline of events. So we checked our logs and traces and everything, and we used also tools like the OVSDB client, which is really useful to trace events that happened in your northbound or southbound database, because you can see there then directly at which time you can see actual the exact transaction that happened in the database and events that happened at that time exactly. So after the debugging, this is only this is not the complete list of events that we had, but these are the main important events. And there we discovered that the post request was sent to plug the port on the destination side. Also from our OVSDB monitor, we discovered that the port plug on the destination hypervisor happened 3 seconds later. And at that moment already the VM got paused on the source node, and the port get removed on the source node. And our test ping that we did to the instance stopped working. At the same time also the VM got resumed on the destination. But 11 seconds after that we saw in the southbound database the entries about our option that we said that we discovered earlier, that the requested chassis option and activation strategy got set. So after seeing that huge delay of 11 seconds between the northbound and southbound, we discovered that it needs to be the north D, which is too slow to get the information from the northbound to the southbound. And as you see also, our ping worked again after the information traveled from the northbound to the southbound. So exactly, after we know that the north D was the bottleneck, first of all we checked the logs and discovered that we see reconcile times there of 30 seconds. And what's also a really big problem, the north D does a leader election over the northbound, and the northbound in our case has so many informations like over 100,000 ports and more than 5,000 routers. It was really slow, by the way. Also the OVSDB is single-threaded, which is also not so performant. We discovered that if there's a leader election of the northbound, that the north D needs to reconnect, fetch all the information until it's active again, and that takes also up to 90 seconds, which is in our case really bad, because during that 90 seconds nothing happens. So if customers create new routers on the API, for example, it gets created in the northbound but not in our SDN behind, so we need to the customer needs to wait for that time until, for example, security group changes or router creates or everything that is network related is actually active in the environment. And it means also if we do live migrations, like if we do live migrations, the customer can lose its connectivity during that time, because no reconcile happens and the information about the multi-chassis port binding is not yet propagated in the environment.
Yeah, I think I take over. Keep this slide. It's not so much time, but we try to solve it now. So we had 2 issues. One was north D is slow, but also the OVN controller needed some time to implement the change. So even the synchronization from southbound to OVN controller took some time, and now we try to get the information when the OVN controller has all the data or has the port applied. We found a not so nice way to fix that, which is in the pre-migration step, first we let Nova Compute create the tab interface. Normally this is created by libvirt directly before the migration starts. But we need to have the port created before, otherwise OVN can't claim this port and then all the flows are not introduced on the source of destination host. And so we first said, okay, Nova Compute, please create this port, and libvirt accept that this port is there, as libvirt fails because it says there is already a port. And then Nova Compute, we built some busy waiting into it to check if in the local OVSDB is this flag OVN installed, which means the port is now claimed by OVN, the flows are applied. Yeah, and after that is done, we can continue. I did the fun to contribute this to Nova, and of course got the result or the answer, don't do that way, because Nova does stuff it's not responsible for, though it's waiting for neutron information, and it's doing stuff with ports with this. Maybe Nova can start or trigger a bit, but it's not the task of Nova to do. We also did some other improvements that speeded up OVN quite fast. So we upgraded to OVN 2403 and had some or contributed some changes like BFD incremental engine or NAP address incremental engine, which also speeded up OVN quite fast. Though to be honest, currently I'm not sure. I think we got from 30 seconds to now 3 seconds that the North-D needs to reconcile data. But still, 3 seconds reconcile is too slow.
It also depends what triggers the reconcile. So most of the time we saw it for the BFD stuff or NAT addresses stuff that we fixed and contributed also upstream. So we added the incremental engines, but we have still the issue if there's been full failover of the northbound, the reconnect takes so long, and we have that issue.
Okay. So yeah, that's a solution that works, but is maybe not the best. Yeah, because so we have it actually running in our environment because we needed to be able to live migrate again, especially when you have some kernel issues also that we saw the last month often. Then you want to be able to live migrate away so you can update the node and so on. So we have this fixed in production, but it's really not nice. So now the question is, how could this be a nicer solution, though also OpenStack, especially Nova and Neutron, would accept this change. And I now want to present an idea of that that we also discussed already upstream. Yeah, a proper solution. So, like I said before, there is a contract between Neutron and Nova that Neutron does the network stuff and tells Nova when it's done or when it's fine to continue. So there are like events. Nova has an event endpoint, or it's an API endpoint, what is called event, that Neutron can call if something happens. For example, the port is attached now. And this event approach is already there. Some time ago, Nova wasn't waiting for this event endpoint for OVN use case. This had historical reasons because, like we expected also before, that OVN in earlier versions wasn't such reliable, and Nova sometimes missed that event, though it got patched out. But now, I think since the last release or the release before, Nova is waiting again for the event. But Neutron sends the event actually at the time when the transaction from Neutron API to northbound is done. So if we go back, if the information is here, then Neutron says, Nova, you can start with your migration. But we have issues with time here. So still it's too early to send the event. Though we need to change the event mechanism or the place where Neutron sends the event to Nova to say the port is created, you can continue. And that's actually a quite simple change. The if condition is not so nice like I wrote it here, because it's more like negative if and stuff like that, and then it's a bit complicated in the end to see through, but it's one place which already exists, where we get information from the southbound database and can check what is that. Neutron has also a watcher to the southbound database. Maybe not so nice that Neutron also needs to watch the southbound database, but for this case it's quite good, because then we see like an event in the watcher, something changed with the port binding, and we can have a look into this event, what exactly changed. Is it the additional chassis that is changed? So before we had this requested chassis, this is only please apply this port at this and that chassis. Then there is a requested additional chassis option. This is also only please do that, but the additional chassis option or field is the field where the chassis is set into if the port is applied. So we need to wait till the additional chassis field is set. Then we know we can continue with the migration. So the idea would be to patch into Neutron to configure this or to send the event at that place. What we need to do at Nova at this point. Like I said before, currently Neutron, libvirt creates the port. First Nova needs to trigger the port creation. We got from upstream the idea to put this in OSWIF, so that not Nova itself does this, but it's done in OSWIF, which sounds like a good idea. And we need to adjust the libvirt domain that it's okay that the tap device is already there and not libvirt wants to create this tap device. That part we already have in our ugly fix, so we know that this is possible. And then Nova needs to wait for the event from Neutron, but that is something that is actually built in or now again built into Neutron. One issue here is that we want to do that with OVN ports, but maybe also with specific OVN ports, but not with any port that you can create in Neutron, and not any port that that is supported by Nova. So the idea was to put some information into the port database that then also, or in the port entry that then also Nova can check on to know is this a port where I need to create the port first, or is it a normal port where I don't do that? And that's the thing for that property of the port. I have no idea how we could tell that or name that. We need to discuss this upstream. And then it's like this is a bit in an ugly way. This is like it could look like that Nova triggers the tap port creation, and like more or less like this. I put this domain, libvirt domain change that if we said managed no, this is regarding the tap interface, then libvirt doesn't create the interface. Though that's our proposal. There's a Neutron RFE, I think it's called RFE bug, where we discussed this, that we proposed, and I also built a proof of concept upstream to show, okay, live migrations are still working, and got some feedback on that. But of course, it is a proof of concept, so it's only for this one use case, and it doesn't check is it the port where we should do that or not, and got feedback like that, or also feedback like, please don't create the port at Nova, but at OSWIF. But I guess we need some more discussion there, and as soon as I get the time, then we can implement this also and contribute that upstream. So that's it. Do you have any questions about it?
Maybe
yes.
to first state out, we're still running the ugly solution in our production environments, and we want to get more feedback with that presentation on our proposed solutions upstream, and get more interactions and find the best solution.
Yeah.
Okay. How much time did you spend since you started the investigation? Just a rough number.
I think so. Something around a month, maybe one or not all the time, full time on it, but more or less. There was also some other issues where we looked more deeper into OVN and tried to like this incremental changes to OVN was also done. I think it was 2 or 3 months in general till we had a fix then in production deployed. Not full time, but something like that. Yeah.
How would you make sure if the OVN folks decide that, for example, the OVN managed field or the OVN installed field changes now and is not different because neutron, I mean, has already the chassis from the southbound or something like this, but other information that the North D generates somehow for the southbound might be a bit harder if they change something in the North D.
Though the idea is to move away from the OVN installed field because this is like in the OBSDB on the compute host. And to never don't check that, but at the same time, this is that in the local database, in the southbound database, the additional chassis field is set.
Yeah.
Okay, and then we look for that. Of course, OVN could decide to change then that again. Then you would need to change, but I mean, it's like with every else that OVN would change, and then neutron needs to adopt.
So also to state out, the Nova actually checks in our ACME solution for the OVN install tag. And that we can't submit upstream because obviously Nova doesn't care about the SDN solution that Neutron has, so the OVN installed tag will not be there if you use ML2 OVS or anything else.
Was there another question? Further questions? Yeah.
I'm just curious, how do you track the impact of live migrations on your customers? Like you said that you looked at the logs, right?
Yeah.
And you saw, okay, network connectivity logs stopped here, was re-established here. Is that something that you continue to do manually or something like that?
So from the customer or from our users, and luckily this was mostly other product teams, so not external customers, we only got the information from them, so we had no monitoring before that we see that. So they told us there are issues, but we could reproduce the issue with a small VM. So a bigger VM, of course, if the copying the memory takes longer, then it's long enough that OVN distributes the information. Then you don't have the issue. But so we could reproduce it, and then we looked into northbound or mainly southbound OBSDB with, I think it's OBSDB client mainly, and looking into the mainly port binding table. And I don't remember what table or what tool it was. You can check, get the logs at the changes from OVN, but it did, and then you see mainly a really big block, everything that got applied from the North D, and you see, okay, at that point, North D wrote, the North D service wrote into the southbound database, please apply this and that change, and you have timestamp for that. And then at a later point, you see when the additional chassis field is set by the OVN controller, and you see out of there, you can take this time difference. So we checked mainly that.
There's a OBSDB client command, I'm not sure how it is named, like something get logs or something, and if you do that on your OBSDB file, then you get first the initial content, and then you get the incremental content with timeline that changed by time since the last database compaction, which is really useful. I think in our case the database compaction happens every 6 hours, and since that you have every timestamp with the event what happened during that time, which is really useful also if you have some SDN outages or something like that, because then you can directly check which events happened in that time in the southbound or northbound and caused that issue.
So we recommend to do that not on the production database file, but copy it over, and maybe if you run in container. So we are running OVN in Kubernetes containers. Maybe you can copy it out as well, but to be honest, I also did it in a production pod, but not the active one, or not the leader one, but another one. If you do it, depending on how big your environment is and how many changes you have, if you do it on the production database, then maybe you have a log on it, and you have some outage or some short time where nothing reacts. Yeah. Basically, I don't remember the right tool names of the command, but we can look.
Do you have Octavia Force on your productions?
No, we have
It's a different solution. Yeah. but I guess you would see the same issue also with Octavia, of course. Maybe, probably it's harder for the team that would then maintain that to see the issue or find that out. But yeah, you will see it there as well. Further questions? Yes.
You mentioned the single-threadedness of the
OBSDB server.
Yeah, is that MySQL's fault? Is it the code that's operating?
No, it's a own code by the OVS guys, and I think there were proposals to make it multi-threaded, but I think there's nothing yet, and it's still a big pain point. Also, what we saw, if multiple clients reconnect, so if you have 2,000 hypervisors and all of them reconnect to the southbound at the same time, for example during an update after a schema change, all clients will connect at the same time, refetching all the content with a new schema. That's a really big flap, first in the network, and the delivery from the single-threaded OBSDB server is a real pain point in CPU time. What we are running is OBSDB relays. It's like database relays in front of them, like 20 or 30 of them, which helps there a lot, but it's still also a problem because they need to fetch it also already from the leader OBSDB server.
Okay, thank you.
Further questions? If not, thank you that you listened to us and was going for lunch.